Hey guys, welcome to video 2.7. We're going to talk about basic electron configurations in this video. Before you watch this video though, you need to have done the practice that was before this, okay? The POGL practice, because it's going to make what we're going to talk about from here on out in the next couple of videos a whole lot easier. So if you have not done that, you need to stop the video and you need to go and make sure you do that POGL exercise, or else you're going to be completely lost when we start moving into other stuff. Anyway, so configurations, guys, have your reference tables out because we're going to see that. They're a dash chain of numbers that are found in the lower left corner. Of an elements box, okay? So we can see that below in a second. What these do is they tell us the number of energy levels as well as the number of electrons. In each level, okay? So again, these are basic ones. So on the Regents, your reference tables, they give you basic ones. We'll go into further detail with them because it's going to help us understand bonding a whole lot better. So this would be, as it's labeled there, the electron configuration. All right. All electron configurations on the periodic table are for neutral atoms. Okay, so they're neutral, meaning that their number of electrons is the same as their protons. And it's also what we call the ground state, which we'll talk about in a future video. So for ions, we either have to add or subtract electrons from the last number in the configuration only. All right, so if we take a look here at this example, magnesium, its configuration is 2-8-2. But when we talk about the magnesium ion now, so think, right? To figure out the number of protons, neutrons, and electrons, we're really only looking at protons and electrons here. What does that plus mean, right? It's a positive charge, it's a cation. Cations lose electrons. So then our configuration for this ion now becomes 2-8 because we've eliminated that last 2 because of the charge, okay? It's a good note. We'll talk about it, but ions, cations, guys, they're always going to end with an 8, as well as our anions, but how they come together we'll see as we go along. So bromine, all right, look up bromine. What's its configuration on the periodic table? You should find that it's 2-8-18-7. Now think about the bromine ion. It's a -1, so minus means that we add one more electron. So when we write its configuration out, it's going to be very similar to what we had before, but now it gained one electron to that last number, and it becomes 2-8-18-8. Okay. Now, if you go all the way down to something like barium, okay, it becomes very, very long, but again, you have it, so write it out. Okay, they give it to you, so just copy it down. Make sure you're looking at the right element. Okay, so that would be bariums. Lead, though, and when you get down to some of the bigger ones, noticing at the bottom of the periodic table, they are written in shortcut method, right, where it just says -18-32-18-4. Okay, the first set of like the 2-8, okay, they've shortened it a little bit just to make it a little bit easier on us. Probably won't be looking at too many of those, so don't stress about it. Here's a big, big key idea, though, that we will talk about all year long. These things called valence electrons. Valence electrons, from your vocab, you should know, these are electrons that are found in the outermost shell or orbital. All right, they are the last number in the electron configuration. So that's this last guy here in any configuration. It's always the last one. The term kernel electrons are the inner electrons. They are all non-valence electrons. That term valence means outermost, okay? So definitely make sure that you know that term all year long, because we will be using it, and when we come back to bonding in a few units, it's all about the valence electrons. So let's take a look here. I gave you an example in your notes. You have chlorine, so valence electrons, it's that last number, so 7. Right, if we looked at its configuration, it'd be 2-8-7, so it's just the last one that we're looking at for valence. That means for kernel electrons, we're just adding up all the other numbers that we have, so that would be 2 + 8, which is 10. I want you guys to go through, pause the video, and try these two on your own and see how you do. All right, so nitrogen, if you look up nitrogen, it's 2-5, so we should have 5 valence electrons. And then when you add up all the other ones, besides the last 5, you would get 2. Sodium's configuration is 2-8-1, so it's got 1 valence electron and 10 kernel electrons. All right. So the maximum number of electrons in an energy level, we use this little formula, 2n squared, where n is what we call the quantum number. Okay, quantum number. It's the same as the period number. Okay, so keep track of that. Principal energy level n, 1, 2, 3, 4. Okay, over here we're going to use our 2n squared formula. This allows us to figure out how many electrons each energy level can hold. So if I'm looking at the first period, okay, and I do that math, 2 times 1 squared, so 1 squared is 1 times 2, I would have 2 electrons. Take a look at your periodic table right now, guys. How many elements do you see in that first very top row? There's only 2 elements in there. That's going to kind of be something that we're going to keep track of as we go throughout the year and we start talking about other configurations and bonding. So keep in mind that piece. I want you guys pause the video, try these 3 on your own, do the simple math. So 2 in there for n, so 2 squared is 4 times 2, we would get a total of 8 electrons in period 2, or in quantum number 2. Down here, 2 times 3 squared, so 3 squared is 9, times 2 is 18. And we're going to continue that here. 4 squared is 16, times 2 would be 32. All right? Remember 2n squared. Very, very well could see that in June. We will review it as well. So, third principal energy level, what's the maximum number of electrons? Oops, forgot to switch pens. So again, just 2n squared. Our n here is the third energy level, so 3 squared is 9 times 2. We would get 18 electrons there. All right? So what I want you guys to do, you can go ahead and do this practice on your own, or you can check answers with me or with the answer keys in the binder. Until next time, I'll see you later.